All right, let's talk about two of the biggest headaches in modern physics. I mean, these are deep, fundamental mysteries that have stumped scientists for decades. But what if they aren't two separate problems at all? What if a single, pretty radical new idea could be the key to unlocking both of them at once? So, where does this all start? Well, with a really simple but kind of unnerving idea. Modern physics is being haunted by two numbers. Two values that, according to all our best theories, are so ridiculously, impossibly fine-tuned, they feel like glitches in the cosmic code. They're pointing to a massive gap in how we understand reality itself. So what are these two cosmic glitches? Well, the first is a number that describes an absurd weakness in one of the universe's fundamental forces. And the second? It's a problem so important, there's literally a $1 million prize for anyone who can figure it out. Okay, here's our first number, 10 with 38 zeros after it. That number, it tells you just how much weaker gravity is than electromagnetism. And it's not just a little weak, it's bafflingly weak. I mean, think about it. A tiny little fridge magnet can pick up a paper clip, completely overpowering the gravitational pull of the entire Earth. That is the insane scale of the difference we're talking about here. And that huge, totally unexplained gap, well, that's what physicists call the hierarchy problem. The energy scale where gravity finally gets strong, what we call the Planck scale, is just wildly, crazily separated from the scale where all the other forces live. So why? Why is there such an enormous hierarchy between them? Our current theories just don't have a good answer. All right, so that's problem number one. Problem number two is the mass gap. This one's all about the strong force, the cosmic superglue that holds atomic nuclei together. The theory says its force-carrying particles, the gluons, have to have some minimum mass. They can't be massless. And experiments totally back this up. We never see a gluon by itself. But for the life of us, no one has been able to prove mathematically why this has to be true. It's such a fundamental problem that, get this, there's a $1 million prize just waiting for a proof. Okay, so we've got these two massive problems, and this new framework, it suggests that the solution isn't out there in some new particle or some weird extra dimension. No, it's about challenging one of our most fundamental assumptions, something we learn in grade school. And this is where things get really wild. The proposal is, what if our whole intuitive idea of mass is just wrong? What if it isn't some simple, static property that an object has? What if we need to completely rethink what it even means for something to have mass in the first place? The way we usually think about it is pretty simple, right? Mass is just an intrinsic property. A particle just has a certain amount of mass, like it has a certain charge. It's just a fixed number on its cosmic label. Simple. But this new idea, it throws all of that out the window. It says mass isn't something a particle has. Mass is something a particle is. Think of it as a measure of the continuous work a particle has to do just to keep existing, to hold its own pattern together. They call this idea recursive binding density. Exactly. This quote just nails it. Think about it less like a solid little marble and more like a whirlpool in a river. The whirlpool isn't a static thing, right? It's a dynamic process, a stable pattern that needs constant energy flowing through it to sustain itself. That's the idea here. In this view, mass is simply the measure of that self-sustaining work. Okay, so let's take this new key, this new idea of mass as a process, and let's see if we can unlock that first door, the hierarchy problem. So here's the absolute key to it all. Different forces see this process in totally different ways. Gravity? Well, gravity is universal. It doesn't care about the details. It senses the total work being done to maintain the entire pattern, the whole ocean of binding. But the other forces, like electromagnetism, they're picky. They're specialists. They only interact with very specific features of that pattern, like charge, just a tiny knot in that vast ocean. So when you think about it that way, of course, gravity feels something enormous. It's sensing the total binding energy of the particle. But electromagnetism, it's only interacting with a tiny, tiny fraction of that, just that one specific feature. This means gravity's apparent weakness isn't really a weakness at all. It's just a consequence of its massive scope. It's a generalist interacting with everything, while the other forces are specialists. And just like that, poof, the hierarchy problem isn't a problem anymore. That insane 10 to the 38 ratio is no longer some fine-tuned mystery. It's simply the natural expected ratio you get when you compare the total universal binding energy of a system to the energy of one of its tiny particular features. It's the ratio of the whole to a part. It makes perfect sense. All right, One mystery down. So now let's take that same conceptual key, this idea of mass as self-maintenance, and let's try it on our second locked door, that million-dollar mass gap problem. This reframes the whole question into something much more intuitive, right? Why isn't existence free? If particles are basically processes working to maintain themselves, can they do that with zero effort? And the answer, it seems, is a hard no. Existence itself has a cost. So the mass gap becomes the minimum amount of self-binding work a pattern needs to do to be stable. There's a critical threshold. If a pattern's self-interaction falls below this line, it just can't hold itself together against the universe's natural tendency towards disorder. It simply dissolves back into nothing. Let's just walk through it. A potential pattern flickers into existence. Now, to stick around, it has to actively work to bind itself together. But if the work it's doing is too weak, if it falls below that critical threshold, then entropy, the universe's constant pull toward disorder, wins. The pattern just can't sustain itself, and it falls apart. And this directly explains why quarks and gluons are always confined. An individual quark is a pattern that's below the minimum cost of existence, so it's unstable on its own. But when quarks team up to form something like a proton, their combined binding energy pushes them over that critical threshold. The group becomes stable, even though the individuals can't exist freely. In short, the mass gap is the entry fee for reality. So this one conceptual shift seems to resolve both mysteries. But, for an idea to be scientific, it can't just be a nice story. It has to make testable predictions. So what claims does this new framework actually make? And this isn't just philosophy, this is falsifiable science. The framework predicts that you can calculate both that huge 10 to the 38 ratio and the value of the mass gap right from first principles. It also makes a super bold claim that all those big experiments looking for new physics like supersymmetry to solve the hierarchy problem, they're going to find nothing because there's no problem to solve in the first place. Finally, it says that any theory structured like the one for the strong force, what's called a Yang-Mills theory, will also have a mass gap, period. It all just comes together so beautifully. The hierarchy problem is about the total work of self-maintenance and a specific feature. The mass gap is about the minimum work required for that self-maintenance to even succeed. They aren't separate issues at all. They're just two consequences of the same underlying physics of how patterns hold themselves together. In the end, by changing our definition of mass, the two biggest problems in physics might not be problems at all. They might just be different ways of looking at a single unified process, the physics of recursive binding. And that leaves us with a final, kind of mind-bending thought to chew on. This perspective suggests a radical shift in how we see the universe. What if reality isn't a collection of static things at all, but a dynamic, cosmic ecosystem of patterns, all constantly working, constantly struggling, just to exist?